Okay, so pyramids and cones. Yeah, just more shapes. Really going to be similar to the other one, right? This one's going to be really similar because all we're really going to do for pyramids, do you guys see that a pyramid could just be rewritten as a rectangle and then times 4 triangles? That's it. We're just going to do like the same type of thing, right? Where we'll just find the area of each and then add them all together. Now, surface area of a right cone. This is one that I didn't put on your formula sheet yet. So can you guys actually write this one down? So for a cone, can you do your best to draw a cone on your formula sheet? I'll show you. I'll give it. So what you would do, make like a bit of an oval, make like a point up at the top, and then connect that point to the sides.
I'm not an artist, Mr. Brown.
And then we can write this down where it's going to be pi r squared. So here, so I'd label on this r. And then the only other new one that you guys haven't really seen much of yet would be this one. It's the S, and the S stands for slant height. So this would be S from like here to here, going down like that. It's because it's all slanty. Yep. And then this is our formula. We can really just think of it this way. It's going to be the area of a circle, and then the area of like all of this stuff, the top part, if you expanded it all out, would be the same thing as just saying pi times the radius times the slant height. Okay? Yeah, for the most part though, it's going to just be an equation that we can put numbers into. Oh. You're looking for that one? Oh, the actual equation there? Okay. Pi r squared plus pi r s. All right, so again, there's some examples, but let's and use those. They're good examples, but let's do our own here. So it says determine the surface area of a cone with a radius of 9.3 centimeters and the slant height of 16.7 centimeters. Okay, so I'm going to, well, let's draw a cone just to get our bearings here again. So draw an oval, point, connect the sides, and then let's see if we can kind of fill this in. It tells us that the radius is 9.3. Okay, well, that would be this, right? This is 9.3 from there to there. And the slant height of 16.7, so that means this is 16.7 centimeters. Or I'll just leave it like that for now. Okay, and then the formula for a cone was area. Area is equal to pi r squared, just the area of the circle on the bottom, plus pi r s. So I'm going to pause it, and I'm going to get you guys to find the area of this thing. So if we go through this, it'd be area is equal to pi, and then instead of r, what am I putting in there?
9.3.
Right, times 9.3. I put it in brackets. Doesn't need to be. You could write it like this if you want, like times 9.3. Yeah, but I like to put it in brackets, so 9.3 squared, don't forget to square it, plus pi times, what's 9.3 again, right? R is still R, that's still 9.3. No, 9.3, yeah, not squared this time. And then S, what's S?
16.7.
Right, that's the slant height, right? So that's the height up and down on the side there. So then just times 16.7. And what do we get?
760.
So we get 760. And then what are our units? Centimeters squared, yeah, for area. Okay. Okay, let's find out the surface area of this pyramid. This one is a little, I don't know, easier. It's easier to kind of visualize, I think, than the cone. It's like our rectangular prism when we just need to find the surface area of all these different shapes, right? So let's do an easy one. Let's find the area of the square on the bottom first, right? So how do we find the area of a square? Area of a square. the square is easy because it's just one side times itself, right? It's the same number, right? So the area of that square would just be 6.2 times 6.2, right? Length times width. All right, so the area of that square would be 12.4, and then I'll write down the units now too, meters squared. I'm going to do that same method before where I am going to put the square, or I'm going to put a box around that because I'm going to add it up after. All right, now let's find, now that we've done that one, let's find the triangle. So let's find the area of this triangle, right? Like that face right there.
6.2 times 6.2 is 38.
Oh yeah. Okay, that was silly, guys. Okay, so that was not that number. That would have been adding them. So this would be 38.44. Yeah. Okay, so that's what that area was. Now, let's find the area of this triangle. Okay, so what's the area of a triangle? Area of... Yep, base times height divided by 2. Okay, so we're going to go with the area is equal to, and then we just got to figure out which of these two numbers is which, right? So that's 6.2. Is that a base or is that a height? That's 6.2? That's base, right? Because I'm looking at like this triangle. That's like the bottom of our triangle there. So that's going to be 6.2 for our base times a height of... Yeah, can you guys see like this height is going up the face of this thing? Like if that was just a triangle like sitting on its own, that would be the height of that triangle. It's just, you know, on an angle there because it's a three-dimensional object. But so it's 6.2 times 14.4 divided by 2. Okay, so what do we get there?
44.64 meters squared.
44 point what?
64.
64 meters squared. So I'm going to put a box. Actually, I'm not going to put a box around that yet because that was one face, right?
You got 2 of them.
Well, and actually, this one works out nice too. I know what you're thinking. The other side would be the same. But the fact that this was a square, right? This one would also be the same. All 4 of those faces on this pyramid would be the same, right? So I can go with this number, this 44.64, the area of that triangle, times what? Times 4, right? There's 4 of them, so times 4. Okay, so that would be 178.6, you said? 0.56. Okay. Meters squared. And then just don't forget that we just found the area of all like these ones, right? We have to add that to the square on the bottom now, right? So we're just going to add up those two numbers. So 317 meters squared. If you, what's that? Sorry, what? 200. Yeah, that makes more sense. 217 meters squared. Just adding up the blue one and the red one, right? All of our faces, and then circle it.
That's exactly what someone said. Say they actually work at.
Yeah. All right. So another object. So we're just kind of going through all of them, right? Another one is a sphere.
Is it just all the way around?
Yeah, this one is all the way around. Yeah. So a sphere is just a ball, right? We're just finding the area of a ball in this case, and it's actually kind of neat. I'll maybe show you guys a video after how you can like prove the area of a sphere. Sometimes there's like different ways to do it, but in the end, the surface area of a sphere ends up being 4 times pi r squared. Well, that's it. I'll show you the video and we can kind of show you like why that works out. It's kind of neat. But yeah, so now let's just do an example of that. It just says determine the surface area of a sphere with a diameter of 5.6. So we always want to just write down the equation first, right? So let's write that down. So the area of a sphere is equal to 4 pi r squared. Which is really like just 4 circles, right? But that's what it works out to. Okay, well,
Which I don't think that's hard.
what's wrong with our number here though? 5.6. So like really if I find the radius, right, then that's all I really need. I just need the radius and that's going to tell me the surface area. Or I can just plug it in and find it. But that 5.6, that's not the radius, right? That's the diameter. And when I say diameter, if this was a three-dimensional object, right, or like a sphere, then 5.6 would be from here to here. That would be 5.6, right, from like there to there. So I want... We need to figure out the radius, right? So what's the radius going to be here? 2.8. How'd you find 2.8?
5.6 divided by 2.
Right, the radius is half of the diameter, right? So we're pretty good to go. Okay, so all right, so let's fill this in, and I think we're good now. So
Now round it to the nearest tenth.
so the area is equal to, and then I'm just gonna write this again, right? 4 times pi, and then instead of an r, what am I writing?
2.8.
Right, 2.8 squared. And then that's pretty much it for like simplifying that or like writing things out. So let's just actually get our calculator. So we'll just write 4 times, and I have a pi button, but you could do 3.14. And then times 2.8. And then don't forget to square it, right? So that's that square button on mine. That's like x to the power of 2. It's like a quick and easy like squared. You guys might all look a little different though too, right? But so squared, and then don't forget to push equals. So I get 98.5. So the area is equal to 98.5. And then just lastly here, you could leave it like that too. It'd be 98.5 centimeters squared because we're looking for the surface area. But then it might also be rounded. So the area is equal to 90, and the 5 would round it up to 99. So 99 centimeters squared. So depending on what they're asking for there for units.